let's take a look at how we do multi-threading with Godot 4. I'm going to show you how to use multi-threading in version 4. Like load something into your current scene. Alright, so all I've got here is I just have a control node with a progress bar. I'll be using a Sprite 2D node here. I'm just going to go ahead and move it down here, and this is our scene that we're going to be, well, I'm going to be using inside of my node. Save that. This node 2D scene is going to be extremely long or extremely big here. And this, all this is going to do is, this has purposely for trying to get it to spend a little longer so we can actually see a little bit of loading happening. I've got thousands of these sprites here in this scene, so you can see this, what it would be like with loading, I guess, like thousands of different objects in there. Of course, these don't have scripts and physics and all that, but I just need some way to slow that down a little bit. So I'm going to be using this scene for loading inside of our script. And my control here on its script, I just have our process function, I have our ready function, and I have an on-game load function, which is what I'm going to be using with my, with the threading. Then I have an await here just so that we have, I'm putting that 3 seconds in there just so that we can wait for the thing to fully load up. Otherwise, it still loads too quick, and the progress bar, you're basically just going to see it at 100 from the start. And I want to avoid that. The variables, depending on what we need here. But I've got progress here. I've got one for a scene and one for a new thread. Alright, so depending on what we want to do here. Now, let's go with just getting something returned back to us. Alright, so for example, we can come in here, right, on game load. We're going to return some type of string, and whatever it is, doesn't matter. Alright, we can do some kind of calculations, and what would come back to us. You know what? I'm just going to go ahead and set up some of our loading. So if you want to use just the built-in multi-threading to load up a scene in Godot 4, we go ahead with resource. We use the resource loader. Load threaded request, and this used to be our interactive loader from version 3. This takes 2 arguments. We're going to put in a string, so that'll be that node 2D scene with thousands of objects in it. And the second one is actually going to be I'm going to pass in the progress, and that's going to give us some information for using later. I'm sorry, not in progress, is in a different one. So in here, all we need is a string path directly to our scene. And now we can go ahead and we can just return a string of some sort, such as complete. And now you can see we could go ahead and run on game load just like normal, right? This is what you would normally do when you're calling a function. Go ahead, you load it, boom, there it is. And then typically, right, we would go create this temporary variable, store our function to it, it gets returned to us, and then we can come in here, we can print out S, right, and we can get that data that's been returned. And of course, that's going to take a second, as you may have seen down there in the output. The complete doesn't pop up fully because we're still waiting for this request and that to go through. But what we can do instead is we can actually use, and this still exists in Godot 4. If we were to use that new thread, right? So if we were to use thread dot start, and the callable or function that we want to call is going to be on game load. And of course, if you want to, you could put in another priority if you wanted to. That still exists in here. For us, we're not going to need it. I'm just going to leave it on normal. Then all we have to do now is wherever we need that, we can just call thread.wait to finish. And then once the function that this thread is running, right here, has been completed, this is going to give us back whatever has been returned to us, which is this string. So if you have a thread that's specifically running something in the background, you're waiting for that data to come back before you can proceed to do something else. There you go. That's how you can do it if you want to run that on a separate thread. Now, we've gotten running this on a separate thread, and using load threaded request is loading our scene in the background. Now, the question is, how do we show the progress on the bar for how far that scene is loaded? How do we load that scene once it's done into our current scene? And how do we take that and load that to go into another scene? Well, we're not going to need thread start, and I'm not going to need anything returned, so I don't have to worry about the printing there. Actually, all we're going to do here is we could just call our on game load here. But more importantly, down here in our process function, where I'm going to go ahead and do this because we want our progress bar to update. Now, you could always just use a function for when the value changes, you can update it. And so you can try running this on the value change signal if you wanted, but I'm not for this. I'm just going to go ahead and just show you it here. So I'm going to create a new variable called load status, and it's going to be equal to our resource loader dot load threaded get status. And now we're going to have to pass in a string, right? A string path. So we can tell it, hey, check up on this scene that's being loaded and let us know the status. And this is where I'm going to use the progress variable that we created at the top to have our information output into. All right. So now we can come in and we can say progress bar dot value equals progress. Now, this is going to be a bit of a problem if we try and run this. We're kind of going to come into, yeah, we can't set an array, we need a value. Okay, well, what if we just tried putting in load status? Then what happens? Okay, well, we haven't crashed yet, and we can see it starts to go up, and it stops at 3. Now, it stops at 3 because the status is either going to be it's going to be one of a couple numbers, and that's it, right? There's only a couple options for that, but that's not what we're looking for. We want the actual progress of it. So if it's not load status, then it must be inside of our progress. And it is, actually. It's going to be 0. It's that first argument. So let's see what happens when we put that in. What do we get for a result on our bar? Okay, well, that went up to 1, which is fantastic. But it doesn't go any further. And the reason it doesn't go any further is because this is actually a float. So we're working from a 0 to 1 value instead of a 1 to 100. So if we simply just multiply this value by 100, we're going to get the integer value of it. And we can see this bar is going to go up, and it's going to go up pretty quick. There you go. So there's how you can do your load bars or your load meters in the corner, just displaying how far that scene has loaded, however it is you want to display that. But that's how you would go about it. It's as simple as that, just those 2 lines there. Check the status and progress and update the value. All right, so we know how to wait for a thread to finish and get the returned value or the return piece of data from it. We now know how to do our loading bars. Now, what about when we want to load an object into a scene or change scenes? Well, what we're going to do is we're simply first going to check if load status is equal to our resource loader dot thread load, and you can see we got different options here. So we got failed, invalid resource, in progress, and loaded. So if it is fully loaded is what we're saying here, right? So the thread that we're loading this scene on this request has been completed. It's fully loaded, ready to go. All right, we could go in here and we could just say, hey, loading done. And apparently I got those backwards. Here we go. All right, we can say loading done. Oh, got all capitals there because apparently I hit caps lock. Print. There we go. All right, and likewise, we can come in here. We can put the other statuses in, or we can simply just say, hey, match the load status. But for now, I'm just going to go ahead and put a print. And this just says still loading. And this is just so we can see it down inside of the output there. So we see it says still loading this entire time. And it changes to say loading done as soon as it's fully loaded and our bar has gone up to 100. All right, so when our loading is completed, we need to actually be able to store this scene or use this scene, right? So let's go ahead. I'm going to take that scene variable that I'm using at the top, and I'll set that to resource loader. Now we have to get the information out of that thread. So we're going to say dot load threaded get, and we'll put the path of the scene in for the data that we're trying to get out of it. This way it knows. Really, we have our scene here and ready to go. So we could come in here and just say, hey, right? We can come in, we say get tree dot change scene to packed and pass the scene in. Right, so we can do it that way, and as soon as this loads, you'll see it change. Right, so we're in this new scene now. It went up, it hit 100. It was just really quick, so it looked like it stopped in the middle. But it hit 100, and we changed scenes. So now, obviously, if you're going to use this for like a loading screen like this, you're going to put some kind of transition in there, maybe a fade out of your text or your bar, whatever, and then fade into your scene, or however you're going to go about doing that. But that's how you would change the scene once we've gotten it. And as you would expect, right, you would come in and you might be like, oh, okay, well then add child, and we could just pass in the scene, right? And you go ahead and try to load it, and let's see the result that we get. And we actually run into an error. And the reason for that is just the same as normal, right? We've got our scene loaded, but we need to create that instance of it. So let's call instantiate and try running it. And let's see what happens. Does this pop up on our same scene? And yes, it does. There you go. So now you know how to load this on a separate thread. Load that scene into your current scene. And how to get that scene and then change to that scene. So you can use it for a loading screen. As well as you know how to run data on a separate thread or run a function on a separate thread and wait for it to finish so you can use the returned data. All right. That's the gist of it. Really, it's quite simple. It's been really simplified when coming to 4. We don't have to load interactive. We don't have to be polling it to constantly check it for information. We can just simply get the status when we want it, or sorry, we can put in a request for it to load the scene. We can get the status to get our information, and we can simply just get that scene out of it. And it's as simple as that. 3 functions is all we need on our resource loader. But alright, that'll do it for how to use multi-threading here in Godot 4. Now, I did see some comments when I was looking around online, and some people did have issues in January at least when modifying the scene tree with this threading and that going on at the same time. So let's take a look. So I've gone ahead and I've just created 2 quick variables, S and SI, right? Just loading that sprite in directly. And we can even change this, right? So we'll say global, whoops, I spell it correctly. Dot, right, global position equals a vector 2, right? And we'll just say like, just so we can differentiate them from the others. But you see, we're going to go ahead and add the child before we call our game load. Just pop up over here, and we'll see that loaded just fine. What happens if we run this after we call our background threading, right, to load that scene? Okay, we have no issues there. Let me try grabbing this. So let's put this inside of our thread that's also loading in the background. No issues. We can put this before, but again, I feel like there's going to be no issues here. All right, as expected. So, at least from what I'm seeing, this is at least slight modification. I'm not seeing any crashes or issues. Now, if I tried to just put in s.instantiate here, that is going to give me an issue. That is going to cause a crash, so I will point that out. Right, so I have to store my instantiated version in a variable. So I don't know if that is the crash that some people were having, but from my short experience here with modifying the tree, adding things to it, I am not having any issues personally. I'll just go up, put that in, right, and then I'll just say si.q3. So we'll create it, run the run our threading, and then delete it. And we see it popped in, it deleted, all before the threaded one even loaded in, fully loaded. So, I don't know, maybe the issues people had in January are fixed, or maybe I just got lucky, or they're doing something weird, or some other kind of modification that they never mentioned in their comments. At least the ones that I saw on the forum I was looking at. But anyway, there you go. Take care. Have yourselves a good one. Enjoy multi-threading. Hopefully that helps some of you guys out that are maybe using 4 for the first time, or coming from 3 to 4 and noticing that everything is completely changed for multi-threading.